what we are doing, what we are thinking within the Google Lunar X Prize competition to the moon. So today we're going to talk about what we're doing in rocketry, robotics, and private enterprise. That's our country there, and the main office headquartered in Santiago, the capital here.
Thank you. Well, good morning. I want to tell you about how was our design and build rocket motor for the lunar stage. Well, the beginning of our design is about the analysis of the mission that we determined that we need increased velocity about 1 kilometers per second. When we have this decreased velocity, the next step was what kind of propellant we need to use to produce this decreased velocity. We determined the best option about the mechanical properties and about the about the total specific impulse. And so we have chose a classical propellant, ammonium perchlorate, HPV, you know. And the next step is chose to grind geometry. We chose a phonics for behavior neutral. Well, we hope to do the first test the next month to test the pressure, instability of the combustion. Hello. Carlos?
Okay, thank you, Dario. First of all, my English not very good, so be patient. My name is Carlos Pino, and I'm the vice chief of rocketry propulsion systems of the team Angelicvm. For develop the X1 engine that we are developing, we have to make some tests, and for that we have recently got a new test facilities in which one we test our first solid rocket engines. The reason because they are small is because we want to prove that the calculus that we are doing right now that the calculation is okay and no and it doesn't have too many mistakes, because the X1 engine is too much big than these small rocket engines. So I will let you Mauricio, who is going to talk about the rocket.
Thank you, Carlos. I'm Chief Rocket Development from the Angelicvm team. We are working, well, for me it's more easy because I don't care how we reach the moon. I just have to build the rover. It's not so easy. So we have a prototyping methodology in which we start with brainstorming from research, a quick construction phase, and test one and again. We are at stage 4 in our cycle. I have a lot of slides, but I'm going to pass it very quick. We start digging what is outside, what other team was doing. Of course, what experience have NASA from rovers, especially on Mars. We decided to take a bio-inspired approach because we know that insects here on Earth are very happy on uneven surface or hazardous surface. And so we take that approach and we start our designs. Due to mission restriction, we are trying to think on the smallest rover possible. So we start digging. So what will be the smallest possible rover that we can build, the minimalistic, and that can be scaled. And of course, one of our main concerns on uneven surface is that the rover can be fall or can be roll up. So we decided to make a reversible design of the rover to be comfortable on those surfaces. We are mainly targeting the moon surface, but we are also thinking on asteroids and possible Mars for our rover. So we end up with a multi-platform robotic design that can be scaled from micro. We call it dandelion because someone thinks that the spurs of the blade on the wheels are similar to the dandelion flower. So can be built from the micro version, passing to the mini dandelion, which is a CubeSat size. The full-size dandelion version that is more big and can be more experiment on it, and a heavy-duty version that is on the edge. Of course, when you think that you have an original idea, it's not that original. There are other robots with 2 wheels from toys, from also the Axel clean-wheel rover from NASA too. So it's not so crazy to think in a 2-wheel rover for space exploration. Of course, we are working on softwares too, from 3D mapping and obstacle detection, path planning, of course, a lot of simulation, and we are taking some approaches from the walking approach that the institute uses. We are lucky that on Chile we have the Mars facility at the Atacama Desert, which is big for Moon Mars Atacama Research Station, which have a pretty similar surface to Mars and the Moon, so we are testing over there. We are several built in the stage. Here are some pictures of our different models of the rover. This is the last one. This is the smallest fellows. It's called a nano dandelion and it weighs just 20 grams. Here are some photos and results of our test over the Atacama Desert in our facilities in Chile. And well, we are very happy with the result of the test. We are happy that this design that use as much space that is possible for chassis and also use the same space for the wheels. And we are looking to work with the small material to bend the wheels with the same heat of the moon surface. And we are testing that and it's working very good. We also have a research area in which we are, as I was saying, looking for different methods to collapse the spurs of the blades, and one of these is the small material approach, which is working very fine. Yeah.
So I will talk about what we're doing there. There's actually 2 universities working together. It's Universidad de Concepción and Universidad Austral de Chile, along an investment company, Angelicvm, in a period of time where you may have heard in the news that national educational leaders, students, are claiming that enterprise and education cannot be together. We are an example. of an effort with the two universities and private enterprise that things can be done for the good of the country as well. We see great benefits in what we're doing. Along science and technology development, which is something very good to have, also we see a culture improvement. In a way that because of the inspiration, the X Prize Foundation, with the support of Google, and of course the previous inspiration from NASA and from all the people like you, as Chileans and private enterprise, we are the first ones trying to achieve things in aerospace field. And we believe that trying to reach the moon, and we know we're going to do it, is going to be an example of that you can follow your dreams going step by step. Today we're doing baby steps, but maybe this in a few generations is going to be quite an achievement for the country. And as we go along, we show respect, and we take you as a guidance. We don't want to mess up. We want to follow the rules of the people who've been there before, and of course we want to be a contribution to the system, not someone who may be doing things in another way. So this is very important for us in our foundations. And we seek an opportunity in the Google Knowledge Prize. We are interested in the aerospace field for the long term. We would like to have self-launching capabilities for the flexible, for going to the moon and other places, more flexible agenda. And of course, we want to inspire the next generation of Chileans and people of other countries that may have not been started yet their interest in the aerospace field, which has many benefits along the path. We just signed a contract last week with Earthrise Space Inc., which is associated to fellow team member Omega Envoy. It's a 1.6 million contract. It was a very big step for us, and in that way we will be able to reach the moon by the end of the year 2014. We did this because, as I told you, we were the first in Chile trying to develop aerospace technology, and we found out that we wouldn't be competitive if we would try to achieve everything. If we didn't have the rocket resistance, the launching capability, we didn't have even the materials, proven materials, aerospace grade and everything. So we decided that we will still do it, but we will need to hire some services from third parties. And we talked to a few providers, which are not many in the world. Say we want to have a quote on to get to the moon. There's not many, and we found Omega Envoy was really following our spirit of cooperation, of student-centered universities, and we will be on their lander along their own road. And we would like to say one more thing. This is actually taken at the Smithsonian Aerospace Museum in Washington, and this is a phrase that they said when they lived the moon on Apollo 17. It says, "God willing, we shall return with peace and hope for all mankind." And for Team Angelicvm, it is very important to use the tribune that is going to be, everybody's going to be watching when we get there to the moon, especially in Chile. This is going to be a first for Chileans. We are 17 million people there, and we want to send a message of unity, of peace and hope, of faith, we really think that the aerospace may be one of the few things in the world that gather people from everywhere, from every age, and makes a difference in being a more peaceful place to develop creative things. This is just many of the people working in Chile, from Puerto Montt, Concepción, and Santiago. So some of the videos you will see, and we can answer the questions while you see the videos.
Any questions? Or people just watching the video? This is a good way to not get questions thrown around. What mass do you anticipate your rover hitting?
What mass?
What mass?
Our goal is to be around 1 kilogram. We are currently working on the heat issues of the mission, so that can change a little the mass of the rover needed for volume to control the heat. But our target, and we are working hard to be in a CubeSat small factor, about 10 by 10 by 10, and our rover will be like 8 by 8 by 9, maybe.
Now, where is your camera? Part of the Google X Prize is to send back imagery.
Yeah, we are working with a potential electronic provider, and the camera is going to be on front. We are looking for 1 or maybe 2 cameras. It depends on what electronic can do right now. We are mainly, of course, we need the HD camera. That's a rule for the Google X Prize. We are looking to add a deep camera to take a 3D stereographic picture of the surface of the moon. Well, that depends on what the electronic can develop now. We are pushing our current electronic CubeSat development companies to be smaller and to provide the smaller electronics possible.
So with a rover that size, you've got a potentially limited line of sight to the lander for your comms. There's a certain distance you have to go for the prize, so there's a reasonable chance you're going to be out of line of sight. Do you have the software autonomy to go and then come back?
The Google X Prize don't say that you need to go in a straight line. You can do any other smart figures like we want to do that because it's a very smart way to get backward if you lose signal, where we need some autonomous capability. At least we are a small size, so our rover is not going to be very smart. But at least a minimum amount of capability, autonomous capability, it have to recover signal in case of loss, like begin a backward where he start to move.
It's 500 meters over a controlled, interesting path consisting of a series of waypoints. Yep. And you do have to tell the X Prize, at least as I recall, Red, if you're still there, you do have to travel, you do have to define those waypoints in advance.
But so it doesn't need to be a straight line. But it's not to be a straight line.
No, it does not have to be a straight line, but it does have to be a defined path. And it has to be a defined, interesting path with consisting of a series of waypoints that you can achieve, and that you can demonstrate that it traveled exactly 500 meters or more.
Larry?
Yeah, I'm really impressed about your enthusiasm in going about this. As an old-time lunatic, I really
I really encourage you to keep going. I mean, this is fantastic. I think you're really on the right track to really building a good presence in Chile of space exploration. Thank you very much.
Thank you very much.
Thank you. We're going to, you've been so well behaved, you can have a slightly longer break. We'll start again at 10:45.
You don't want to miss it because it's 5 years.
We'll start again at
Right away. Well, everybody that looked the video, always say as well, it looked like a spider, it looked like an insect, so it brings the image of an insect right away. So, and our project, what I don't personally like from much of the rover is that for a just hazardous surface like the moon, and the moon is even worse than Mars, hazardous surface, that you have really good chances to roll over or tip over. So we want something that feels comfortable. And the books, they run over sand, run even over water.
The little craters are all the size.
But these guys were bigger over. So there is a first question that is very valuable, and we are trying to get that.
And we have to simulate as close as possible the target and the properties of that kind of surface. I definitely agree with you. Thank you very much. Okay, thank you. Thank you.
A certain metal, I think it's called nitronol.
Yeah, we are using that.
Okay, that's what I thought.
Well, to be able to put our rover in a CubeSat form factor, we are using, and we are actually right now having a good contact with an ethanol provider. Okay. So he is very sure that can be manufactured the spur, and the spur we are going to cover all the rover in a spheric shape. So with the surface temperature, we hope to can break the spur up and then take the final exploration mode.
I would like to introduce you to the president of the company who was here earlier. There he is standing up. His name is Russell Cox, and he's from Fletcher Engineering. They are a testing company that can do vacuum testing for conducting.
¿Cuáles son las impresiones? No fue muy bien a pesar de que nuestro inglés nos defendió, pero hemos logrado muy buenos contactos. Espero que hoy día nos vaya mejor.
No comentarios, por favor.
Hoy súper contento de la presentación que hicimos, súper contento también del feedback durante la pregunta y también después de que terminó, incluso en el break, mucha gente que se ha acercado, nos ha dado sus tarjetas, ha demostrado actitud de cooperación, nos quiere presentar más gente, hay gente que ha estado aquí en las misiones Apolo revisando la superficie lunar, hay gente que tiene materiales de tipo flexible que nos pueden servir mucho, gente de NASA que trabaja aquí normalmente y que también ha trabajado en landers y módulos lunares, así como la de ayer, que imagínate, conocimos a uno de los últimos en pisar la superficie de la Luna, así que muy contento con la participación acá en Goddard NASA Center. El Team Angelicvm, por estar presentando aquí en NASA, primero hace un trabajo de difusión de lo que está haciendo la empresa privada aeroespacial chilena, hace un trabajo de embajador también de nuestro país, en el que estamos pensando con visión de futuro, estamos pensando en ciencia, estamos pensando en desarrollo de tecnología y también nos empiezan a mirar de una manera como una cultura capaz de desarrollarse, capaz de pensar en sueños, ponerse objetivos grandes e irlos cumpliendo paso a paso. Así que, además de eso, está el hecho de poder tener contacto directo con un Buzz Aldrin, segundo hombre en pisar la superficie de la Luna, en el Apolo 11. Tuvimos contacto también con Jack Smith del Apolo 17, el comandante del módulo lunar, que es muy entretenido porque nos muestra unas diapositivas con sus fotos. Entonces nos dice, mira, aquí yo estaba sacando unas muestras de roca lunar, esta es mi foto y está él con su traje de astronauta. Realmente es algo impactante y no solo eso, sino que de muchas universidades y otras instituciones, incluyendo la propia NASA, nos ofrecen ayuda al solidarizar y al simpatizar con este equipo que forzadamente y apunta de una visión y de un sueño y de querer hacer las cosas con entusiasmo y actitud positiva frente a la vida. Eso los motiva y los sensibiliza para ofrecernos ayudas de distintos tipos. Nosotros esperamos que esto sea fuente de inspiración también para otros chilenos, para el propio país, y sea algo realmente bueno para el desarrollo cultural de Chile.